A black hole the size of a forgotten god is racing toward Earth at a speed no telescope ever wants to witness. We only have one choice, and it is not to hide. It is to destroy the most powerful object the universe has ever created. Scientists say nothing can escape a black hole, yet today we are going to try something humanity has never dared to imagine. We are going to fight back. So the question is simple. Can we actually erase a black hole from existence? Or will our first attempt become the moment we regret forever? Get ready, because the first method we are about to try looks outrageous, and it just might surprise you. But will it work? A black hole is not just an object in space. It is a place where matter collapses into something so dense that the rules of physics begin to twist. Its gravity pulls with a hunger that nothing can resist, not even light. If you drift too close, you cross a boundary scientists call the event horizon. And from that point on, escape becomes impossible. Time slows. Space stretches. And if a person fell in feet first, the force would pull the legs downward while squeezing the chest upward, turning the entire body into a long, thin thread. Astronomers even have a name for this, and they call it spaghettification. It sounds almost funny until you imagine it happening to anything that gets too close. And here is the real problem. If a black hole were to approach Earth, it would not need to collide with us to destroy everything. Its gravity alone could bend our orbit, tear apart the moon, and rip the atmosphere away like dust in a storm. Oceans would rise into the sky. Cities would crumble. Even time itself would lose meaning as the planet is dragged into a place where nothing returns. So if a black hole is this unstoppable, what happens when we throw our strongest weapon at it? And is there anything even more extreme we can try? Our first plan sounds simple. Gather every nuclear weapon on Earth, every warhead, every experimental device, every last piece of destructive power humanity has ever built, and aim it straight at the black hole. The logic seems obvious. If we unleash an explosion large enough to level continents, then maybe, just maybe, it could tear the black hole apart. So we fire the rockets. Hundreds of missiles streak into space and detonate in a blinding flash that could rival the birth of a star. For a moment, it feels like we might have done the impossible. Then the light fades, and reality hits harder than the explosion itself. The black hole does not break. It does not even flinch. It simply absorbs the blast, the fire, the radiation, all of it pulled inward like crumbs falling into a cosmic vacuum. And as it consumes that energy, something terrifying happens. Instead of shrinking, the black hole becomes a little larger, a little heavier, and a lot more unstoppable. If even our most powerful weapons only make the monster stronger, then what happens when we try something that is not ordinary matter at all? Could antimatter or a man-made black hole finally make a difference? If nuclear fire cannot scratch a black hole, then the next idea sounds like something straight out of science fiction. Antimatter. It is the mirror version of normal matter, with every charge and property reversed, as if the universe created a rival twin for everything we know. When matter and antimatter collide, they erase each other and release pure energy, which makes it tempting to imagine a weapon built entirely from this exotic material. So the plan is bold. We create an antimatter black hole and send it on a collision course, with the monster racing toward us. Picture the scene. Two cosmic abysses speeding through the dark one, made from the familiar elements of our universe, and the other made from its inverted reflection. When they meet, the collision erupts in a burst of energy so enormous it could light up half a galaxy. For a brief moment, the idea feels brilliant. Then reality gently taps us on the shoulder and reminds us of the truth. We have no way to produce enough antimatter to build anything close to a black hole. Even if we could, the real black hole would not be destroyed. It would simply swallow the antimatter version and grow even more massive, turning our last hope into more fuel for the enemy. If antimatter cannot stop it, then what about something even stranger? What about the one thing that behaves in the exact opposite way of a black hole? Could a white hole change everything? If a black hole is a cosmic throat that swallows everything, then a white hole is the opposite. It is the theoretical mirror that does not let anything enter and instead throws matter and energy outward, as if the universe built a cosmic fountain instead of a cosmic drain. No object can fall in, and nothing can cross its boundary, which makes it sound like the perfect weapon to fight the monster rushing toward us. So we imagine a scene where a white hole is hurled across the void, aimed directly at the black hole. When they collide, the eruption of energy would be so violent that it could rival the birth of the early universe. A blast like that might seem powerful enough to tear space itself. But there is a problem, a very big one. We have never seen a white hole. Not once. Not in any telescope, not in any simulation, not in any corner of the cosmos we have mapped. And even if a white hole exists somewhere, we have no idea how to build one, no idea how to move one, and no idea what would truly happen if it touched a black hole. The truth is simple. White holes belong to equations, not to reality, at least not yet. Which raises a troubling question. Are we fighting a real threat with weapons that only exist inside our imagination? If white holes remain only on paper, then what happens when we reach for something even more impossible? Could time itself become our next weapon? When every weapon we know has failed, the mind begins to wander toward ideas that sound impossible, yet strangely tempting. If we cannot defeat the black hole in the present, then what if we reach into the past? Imagine building a wormhole, a bridge, through space-time itself, and steering a ship into that impossible doorway. The vessel slips into darkness, where time folds like soft fabric, and the stars stretch into shimmering lines. The universe bends around it, as if reality has become a sheet being pulled in every direction. On the other side lies a moment before the black hole was born. A star still alive. A core not yet collapsed. In theory, we could strike right there at the origin, erase the black hole before it ever existed, and save our future by rewriting our past. It is a dramatic thought, and it looks magnificent in the mind, like something painted across the sky of a science fiction epic. But then the truth settles in. We do not have a time machine. We do not know how to create a stable wormhole, or survive the forces inside one. And even if we could, the consequences of rewriting the past would be unknown and possibly catastrophic. Time is not a weapon we understand. It is a mystery that sits far beyond our reach. So we are left here in the present facing a monster that grows larger by the second. If we cannot destroy a black hole from the outside, then what happens if we try to weaken it from within? If destroying a black hole outright is impossible, then maybe the answer is not brute force, but sabotage. A black hole is not just a void. It has structure. It spins with unbelievable speed, and in some cases, it even carries an electric charge. These properties keep it stable like the rhythm of a beating heart. So the idea is bold. If we cannot shatter the black hole, we weaken the rhythm. We steal energy from its rotation, slow its spin, drain its charge, and push it out of balance. Scientists call it extracting rotational energy, and in theory it is possible. Imagine building a device that drops matter precisely into the edge of the event horizon, like sliding a crowbar into a turning gear. Each carefully placed object would slow the monstrous spin by the tiniest fraction. Do it long enough and the black hole begins to lose momentum. Some theories even suggest that if the spin and charge fall out of the required range, the black hole could destabilize and collapse into something entirely different. The image is dramatic. A cosmic engine winding down, losing the very motion that keeps it alive. But this approach carries a weighty question. Can we really interfere with the fundamental structure of space-time without risking something far worse than the black hole itself? A collapse in the wrong way could unleash forces we do not understand and do not know how to control, possibly affecting regions of the universe far beyond our own. Turning a black hole into an experiment might save us, or it might tear open a problem we are not prepared to face. If weakening the monster still feels like fighting fire with fire, then what happens when the only remaining strategy is patience? A patience so long and so strange, it almost sounds unreal? When every attempt to fight a black hole fails, there is one last idea that sounds almost like a joke, yet comes straight from physics itself. According to quantum theory, a black hole slowly leaks particles over unimaginable stretches of time. This process is called Hawking radiation, and it acts like a tiny whisper of energy escaping the edges of the black hole. Each whisper removes an incredibly small amount of mass, which means that if you wait long enough, the black hole eventually evaporates. Not in years, not in centuries, not even in the lifetime of civilizations. It could take billions or trillions of years for a massive black hole to fade into nothing. By then, stars will have died, galaxies will have drifted apart, and the universe will have stretched into a cold, quiet sea. In that distant era, the black hole will shrink, glow, with its final burst of energy and disappear, leaving no trace of the monster that once threatened us. It is a strangely peaceful ending. No explosions, no battles, just time doing what none of our weapons could. But it raises a difficult question. Can a species like ours, which barely survives for a few thousand years, rely on a solution that demands the patience of the cosmos itself? But if waiting for the universe to blink is our last resort, is there any way to bend time in our favor and force the ending sooner? After everything we have tried, the truth becomes clear. We threw nuclear fire at the black hole and it grew stronger. We built an antimatter fantasy and it swallowed it whole. We imagined a white hole and time machines, and even ways to sabotage the very structure of space-time. Yet every idea either breaks the laws of physics or depends on technology far beyond our reach. Each solution had promise, each one had flaws, and none could guarantee survival. That is the nature of black holes. They are reminders that the universe holds secrets deeper than our current understanding. To defeat something like that, we would need knowledge that does not exist yet and tools that have not been invented. The battle against a black hole is not a battle of strength. It is a battle of insight, a battle of future science. And maybe one day, as physics advances and humanity grows bolder, we will find a method that works. The future is long and full of surprises, and the universe has never stopped revealing new truths. So, if you were a scientist in the year 2125, which path would you choose, and what would you try first? If you have a wild idea about how to destroy a black hole, share it in the comments and let the rest of us hear it. And remember to subscribe if you want to explore more of the mysteries hidden across this universe with me. The cosmos is endless, and every answer we find only opens 100 new questions. Sometimes the truth sits far outside our imagination, and sometimes it only appears when we dare to look deeper. Stay curious and stay critical, and let your mind wander a little farther than usual.